I am now teaching the test cleavage by reagent R. So first I will make the reagent R and then we will do the cleavage. And I need this. I need this. I need 1 ml tip. 1 ml tip. Take it 2 ml. So what I will do first, this is, I will make this equal to 1 ml. Okay. Chemistry thing, it's not necessary to be very much precise. So 1 and then 2. Okay, 2 ml. Now I will take this one and I will make it 50. So I made it 50. Okay, and now I will take this and I will add anisole. I will put it aside so that I don't mix, and I will throw this tip and I will now use this anisole. Okay, done. And then I will put few grains of DDT. I need a spatula. I will add few crystals of DDT. That's it. So now this is freshly made cleavage cocktail. Okay, I will put it here for a while, and now I will take very few grains of this. Okay, so I am going to use the spatula. Okay.
Yep.
So these are the little grains, right? Okay, and I will add these grains in this. That's it. And I'll fix this. Now you see this is the resin, right? Okay, so then I will take the paper towel and just rotate it, and I will label it 237 Imran, right? And after 1 hour I will precipitate it with ether. Okay, that's it. This is diethyl ether anhydrous and it is chilled. It was placed in minus 20 degree, so it is very chilled, right? So I will put around 30 ml of this ether. Okay, maybe it's fine, right? And I will, and now this is important, you have to learn it. So you have to remove this like this, throw it, and then drain this in it like this. Got it? So the peptide is going down, resin will remain at the fit, right? So what I do to get it out, I just push it again like this, so everything is gone. So what is left here is the resin. We have the peptide as well as the protecting groups, right? The scavengers that we added, scavengers like the thioanisole and anisole and DDT, they will bind the PBF and BOC with them, and what we will get is the peptide. Got it? Okay, and then I will centrifuge this for 5 minutes. Okay, let's do it. Then the water to make the volume equal. That's equal, right? And then I will put it here at 4500 RPM for 5 minutes, right? Start. Okay, so Okay. Now the peptide will sediment, and we will remove the rest of the thing into the drain, right? And then we will dissolve that peptide in acetonitrile water, and we will check the mass, right? So to check the mass, what we need so first of all the multi plate. We need the multi plate, and we need CHCA, cyanohydroxycinnamic acid, which is matrix. Okay, and we will mix it this 2.5 microliter of this and 2.5 microliter of peptide solution into this, and then we will spot it on this multi plate, and then we will check the mass of it on the multi plate, got it? The 5 minutes are done, so we are now getting it out. So we get it out. There is a very small precipitate down there. So we will remove this supernatant, and we will mix that with the acetonitrile water to dissolve the peptide. 100 microliter of acetonitrile, and then I will take 100 microliter of DI water. Okay, and then I will vortex it. Now this is our peptide solution. This is our peptide solution. So what I will do, I will take first the .5 microliter of the matrix, into this. Got it? And I usually take like 5 microliter, so I will use 5 microliter rather than 2.5. Okay, and then I will take 5 microliter of my peptide.
1-to-1 ratio.
Yeah, 1-to-1 ratio. And then I will mix it. So I mix it well, and then I spot it close. So I will spot it somewhere. So I spotted it at M. Then I can spot it again at M3. So I spotted it at M1 and M3. Okay, and then I will dry it. Dryer, okay, and which is called hot gun, and we are drying this. Okay, see that at M1 and M3 they are dried. Yeah, they are dried. Got it? We actually put this, and you have to make sure that these things should be forward and this should be here, right? And you should have to remember the spot, which is M1 and M3. Got it? And I will put it here. After putting it here, I will go here to this button, which is eject, and close and see that. So we'll just do this. So once go this, see here, so it's preparing and docking, right? Once it becomes green, then we will start checking the mass, right?
What is the range we're supposed to put for this?
Huh?
What is the range we're supposed to put for this?
Now, yes, this is the mass range. This is the mass range. So here it is checking from 1851 to 4000, but I can change it to 500 to maybe 4000, 500 to 4000, right? So mass below 500 is not easily detected by the MALDI. So if the mass is above 500, MALDI machine is good to check the mass. Okay, and then this is the voltage, this is gain, right? And this is also the laser intensity. But what I usually do is like, this is call par method. So actually we do, we go to file, then we go to select method, then we don't want to save it, and then we go here and we have lot of methods here. So we go to D, and then we go to Imran. So we go to methods, rather we go to methods, and in the methods we go to flex control methods, and from flex control methods we go to instrument specific settings. Here we have Imran, and from Imran I usually use this one. Okay, and now this is automatically set between 200 to 4000, right? Yeah, but I can play with this later. And if you see this is the camera. If you see this is the camera which is showing the spots, right? And these are the spots here, right? So we spotted at M1 and M3. Got it? So here it is in, but it is still preparing. So I have to wait for it to become green. Got it? So once it becomes green, I will go here, and you see that this is moving. And you see that now I can change it. So this is our matrix and the peptide, right? And now I will just push start. And once I start it, so you will see here spectra. It will take, for the first spot, it takes usually around 1 minute to show the mass, right? But after first spot, the laser is good, so it shows the mass very quickly, right? You see that. What is this mass?
1386.
So this is 1386.5447, or this is 1387.5564, right? So if we go to peptide mass calculator, if we go to, and this is the peptide mass calculator, and if I put this RW, and I enter it, so there are 8 amino acids and the mass is 1387, right? So it means that we are able to make our peptide, which is very neat and clean. And then we have to export this. And another thing is that usually for the ACS publications, they need 4 decimals after this, 0.5477, right? So it should be 0.4477. Now next question is how I save it. So I will save it, file, save the spectrum file to as. So I will here browse, and I will go to desktop, and maybe I will go to Imran, and here I will say okay. So it is in D and Imran, so I will name it linear bracket RW4. Save. Got it? And then this is here, right? So it looks like this. So I will go here and go to report, and I will say that first I will have to check the mass. So I will go to mass list, and I will say mass, find mass. So this is the mass, okay? And this is not relevant to us. So this is the only mass that we are looking for. So this is 1386, right? And then we can save this report as PDF, and then I can just save it in my data desktop, maybe computer, D drive, Imran, and I put it here linear R4 W4 1387 1387 June 21 2022 okay, and I save it. Got it? And then I save it. Okay, and another thing is that if we want quick thing, then what we can do is that we can shake the snipping tool. This is snipping tool, and we can just take this image, okay, and we can save this image as file, save as Imran, or maybe Joseph, Joseph, okay, and I put it on desktop and I say it June 21 2021 and it's safe. Got it? I close it, I minimize it, and here should be Joseph. Somewhere Joseph. This is it. Got it? Okay?